Hello students, good time to all. I am Chandan Kumar Pradhan. Welcome to your YouTube channel Chandan Physics. In this video, we are going to discuss photoelectric effect. Let's begin. Photoelectric effect. It's a phenomenon of emission of electrons from surface of a substance. That substance usually metal. When an electromagnetic radiations of suitable wavelength fall on it, is called photoelectric effect. The electrons emitted from that of process are called photoelectrons, and the current produced is called photoelectric current. Let we consider this is a metal surface, metal. Their electromagnetic wave is incident. Light is one type of electromagnetic wave. When that light is incident on that of metal, from that of metal, electrons are ejected. And the incident light is of a suitable wavelength. Next we can discuss what be the wavelength required for that particular phenomenon. The electrons emitted from that of process is called photoelectrons, and that electrons execute current, means they produced current, are called photoelectric current. First of all, the theoretical explanation of such photoelectric effect was given by Einstein, and that theory based upon quantum theory. What was the theory? According to him, by using that quantum theory, as light is not continuous, but it is discrete. Discrete means in the form of packet of energy, which is also called quanta of energy, and that quanta of energy is our photon, and the energy of a photon is equal to h nu, some constant, into frequency of that of incident light, whereas h is the Planck's constant, nu is the frequency of that incident light. So here light is the photon, light is nothing but photon, and each photon have the energy h nu, means h nu amount of energy is incident on that of metal. When light, that is photon, incident on the metal surface, it ejects electrons from it. The condition is that if the incident frequency is greater than a threshold frequency. What is threshold frequency? Threshold frequency is the minimum frequency of incident light below which the photoelectric emission is not possible completely. So threshold frequency is that minimum frequency at which Below that minimum frequency, no photoelectric phenomenon execute, but above that minimum frequency, photoelectric phenomenon executes. So, that minimum frequency is called threshold frequency. So, that incident frequency must be equal or greater than that of threshold frequency, that is the threshold frequency. Now, that the energy of photon is incident on that of metal surface. So, that the energy of photon used in two different ways. One, a part of energy of photon is spent in liberating the electrons from the surface of the metal, and this energy is equal to the work function of that of metal. That the incident photon, the photon of energy is incident. So, one part is used to liberating the electron from the surface of that of metal. That work done or that energy required is called work function. So, work function denoted by W naught is the minimum energy required just for emission of an electron from the surface. The minimum frequency required to emission the electron from that of surface, the minimum frequency, that is the threshold frequency, which is denoted by nu naught. So, the work function is the minimum energy to just emission of an electron from that of surface. So, that work function is given by, that is the form of energy, some Planck's constant into the frequency. So, Planck's constant S into the frequency required, which is equal to threshold frequency nu naught. So, work function is equal to S into nu naught. So, the incident photon now used as a work function, and another part rest, or we call it as remaining of the energy of photon is used in giving maximum kinetic energy, maximum kinetic energy to that of emitted photoelectrons. So, maximum kinetic energy is given as half m v maximum square, m mass of electron, v maximum the maximum velocity preferred by these electrons. The light having the photon of energy h nu incident on that of metal surface, that frequency is greater than the threshold frequency nu naught. So, the process of photoelectric phenomenon executes. The phenomenon of photoelectric effect holds good here. That amount of energy is used to liberating just electron from that of surface of the metal, which is called work function, and that work function is given by h nu naught. Again, another part of that of energy is used giving the maximum kinetic energy to that of photoelectrons. The electrons ejected from that of photoelectric process, that is kinetic energy maximum is equal to half mv max square. Here we can use the law of conservation of energy. According to the law of conservation of energy, the energy of photon, that is the incident photon, that energy is used in the work function of the metal, and kinetic energy which is the maximum kinetic energy of photoelectrons. Electrons ejected due to that incident photon. So energy of photon h nu. Here the work function of that of metal W naught. Maximum kinetic energy of photoelectrons, kinetic energy max. So the values are putted. S nu is equal to work function S nu naught H nu naught plus kinetic energy maximum half m V max square or half m V max square is equal to S nu naught minus H nu or half m V max square is equal to H as common nu naught when half m V max square, that is H nu minus H nu naught. Or half m V max square is equal to H nu minus H nu naught or half m V max square is equal to H whole into nu minus nu naught. Which is Einstein's photoelectric equation. Einstein's photoelectric equation. Next, we can verify that the theoretical result experimentally. Let us come to that experiment part. How experimentally that phenomenon of photoelectric emission is verified. Experimental study of photoelectric effect. In the year 1900, the scientist Leonard studied the photoelectric effect experimentally. His experimental setup: the apparatus consists of an evacuated glass tube and fitted with 2 electrodes. That apparatus consists of evacuated glass tube. In that of glass, there will be no air. If there will be air, then it is at very high pressure. That glass tube is called evacuated glass tube, consisting of 2 electrodes. The electrode P is a photosensitive plate called emitting electrode, and other C is called collecting electrode. 2 electrode, one P, that is photosensitive, sensitive towards light, which is called emitter, that emits electrons, and another electrode which is collector, means it collects electrons. A varying potential difference can be applied across 2 electrodes with the help of a battery B, which is connected to the resistance L. So, the midpoint of which is charged, so that the plate P is at 0 potential. These two electrodes now connected to that of battery B, and it is towards a resistance L, which we called as rheostat, means it is a varying resistance. According to the Ohm's law, there will be a drop of potential, and that potential drop is varying in nature. So, that midpoint is connected to this. First, the potential difference between these two electrodes are 0 potential difference. That the midpoint of which is charged. So, the plate P is at 0 potential. The collector can be maintained at a desired positive or negative potential with respect to that of collector C. And the potential difference between the electrodes is measured with the help of voltmeter, and photoelectric current is measured in the circuit by microammeter. In that of circuit, we use a microammeter which detect the current. In that particular photoelectric phenomenon, the current produced is minimal. That is why we use microammeter. Next, a voltmeter is connected in order to calculate what will be the potential difference between these two electrodes. Next, come to that working scenario. What happened in that of experimental setup? When a suitable radiation is incident on photosensitive plate P, electrons are ejected from it. According to that theory, from that of source, we incident light on that of plate P, which is photosensitive, and that incident light is of suitable frequency, means that the frequency is greater than equal to the threshold frequency. So, electrons are ejected from that plate P. The electrons which have sufficient kinetic energy reach the electrode C despite its negative polarity. Due to that battery arrangement, first there will be the potential difference 0, and we adjust that potential difference by taking that rheostat, means the varying resistance, and that potential difference is measured by that of voltmeter. So, the electrons now ejected from that of plate P and collected across that of collector C. So, the electrons which have maximum velocity, they first reach out that of collector. Despite its negative polarity, that collector is negative polarity, electron is negatively charged. So, electron repelled by that of collector, but some of the electrons are passed through that of collector. As the collecting electrode is made more and more negative, fewer and fewer electrons are reached the collector, and photoelectric current recorded by emitter will fall. Collector is negative polarity, but some of the electrons having maximum velocity are now collected by that of collector. So, we see a deflection at that of emitter. If we increase the negative polarity of that of collector, fewer and fewer electrons, a very less number of electrons are now collected, and a very small deflection we notice in that of microammeter. At a particular potential, means at a particular point, we notice that at a particular potential, that a collector has no electron reach that collector, and the current becomes 0, and that potential here we call stopping potential. As we increase the negative polarity of that of collector, then a point we notice where no current will see in that of emitter. At that particular situation, what be the potential? That the potential is called our stopping potential. Okay, and that the stopping potential here we denoted by the letter V naught. V naught be the stopping potential. So, what is stopping potential? That is the potential offered by that of collector, so no electrons will reach and no current we showcase in that of circuit. That potential we call stopping potential. Due to that of stopping potential, work is done by that of electrons, and that stopping potential we measured the voltmeter connected in that of circuit. The work done by stopping potential is equal to the maximum kinetic energy of such electron. The maximum kinetic energy is half mv max square, and the work done means the energy electron charge of electron into potential E v naught into half mv max square. Now, from Einstein's photoelectric equation, that is half m v max square is equal to h nu minus nu naught. Therefore, half v max square, that is E v naught, h nu minus nu naught. Therefore, the value of h, which is the Planck constant, can be easily evaluated by that formula E v naught divided by nu minus nu naught. From that equation, the constant as known as Planck's constant is easily calculated. Charge of electron, stopping potential that we measured by that of voltmeter, nu, the frequency of that of incident light, nu naught is the threshold frequency, minimum frequency required to eject an electron from that of surface. That is the experimentally proof of that photoelectric effect. We are dealing with that stopping potential and work done by that of stopping potential using photoelectric equation by Einstein, and we notice how the constant, which is Planck's constant, is evaluated from that particular expression. Next, laws of photoelectric emission. As we studied photoelectric emission from that of experiment as well as theoretical result by Einstein, he formulated 4 laws. These laws are like this: the emission of photoelectrons takes place only when the frequency of incident radiation is above the certain minimum value, which is the threshold frequency. That is a characteristics of metal. First, we notice if the incident frequency is equal to or greater than that of threshold frequency, then the phenomenon of photoelectric emission holds good. This is the first law. Next, the emission of photoelectron starts as soon as light falls on metal surface. In other words, we can say that the process is totally instantaneous process within a very small order of time that process executed. This is the second law. Third one, the velocity of electrons emitted is independent of the intensity of light, but depends only on the frequency of incident light. The velocity of electrons emitted means when we incident that light, so the velocity depends upon what be the frequency of that of incident light. If it is more, then the velocity will be more. If it is less, then it will be less. In such a manner that velocity of such electrons that are ejected from that of metal surface depend upon what be the frequency of that incident light, but it does not depend upon what be the intensity of light. Last one, for light of a given frequency, the photoelectric current is directly proportional to the intensity of light. As we say, if the intensity is more, then there will be more number of photons. That is why that more number of photons execute more photoelectrons, and therefore photoelectric current. That is why it depends upon the intensity of light, not the frequency. The photoelectric current is directly proportional to the intensity of light. Why? Due to the intensity of light, there will be more number of photons. More number of photons means they ejected more number of electrons. So, more number of electrons means it will execute more amount of photocurrent. So, these are the 4 laws we notice in case of our photoelectric emission. So, here with the help of this video lecture, we understand the idea of photoelectric effect. What is photoelectric effect, photoelectrons and photoelectric current. Then the idea of photoelectric effect by Einstein on the basis of quantum theory. Energy of photon S nu, what is threshold frequency, and that energy of incident photon is used in 2 ways. One, to that of work function, another giving that maximum kinetic energy to that of photoelectrons. From that of conservation of energy, that energy photon is equal to work function of that of metal plus maximum kinetic energy of photoelectrons. Energy of photon S nu is used in work function, maximum kinetic energy, work function S nu naught, work function as we notice the minimum energy required, just emission of electrons from the surface. From that of surface we notice that is nothing but the minimum frequency, which is threshold frequency nu naught, S nu naught half mv max square. Under simplifying, we have that equation which is nothing but our Einstein's photoelectric equation. Next, experimentally we verify it. Experimental study was performed in 1900 by the scientist Leonard. Construction, here we notice a technical term, that is stopping potential. So, how stopping potential is used for that of work done. So, work done by that of stopping potential, which is equal to the maximum kinetic energy of such electrons. Now, that equation is used in that of Einstein's photoelectric equation. So, we can easily calculate the constant, which is Planck's constant. Planck's constant is easily calculated. And finally, the laws of photoelectric emission from that of experimental conclusion we see. First, what is threshold frequency? Next, that process is called instantaneous, and how it is dependent or independent on frequency as well as intensity of light. So, with this useful and informative notes, let me wind up the session. Thank you.